Alright, so in this particular situation here, number 16, we have a rectangular sheet of tin that's 15 centimeters long and 9 centimeters wide. Okay, so let's start by drawing that out. So there we go. So we're going to say it's, again, 15 centimeters long and 9 centimeters wide. Okay, then what we're doing with this is we're going to cut off a uniform strip around the sheet. So again, uniform means it'll be the same distance from either side. So we're going to cut off a strip all the way around the sheet, and we're going to be left with a smaller rectangle on the inside. So let's just sketch that out. Okay, and what we're told is that what's left over is going to have an area of 112 square centimeters. Okay, and we want to figure out how large a strip was cut off from each side. So again, because it's a uniform strip, it's going to be the same distance cut off from each edge. So that distance we're going to call x will be the same thing as that. The same thing as that. I know it doesn't look like that way according to my diagram, but that's okay. All these are going to be some distance that we're going to call x. So we're going to define x as the width of the strip. Okay, so there's our let statement there. Let x represent the width of the strip, but it's not going to be in meters. It's going to be, of course, in centimeters. Okay, so what we're told is that the remaining area, so the area of the inside rectangle, is going to be 112 centimeters. Okay, so the question is, how can we find the area of that inside rectangle? Well, again, let's use the dimensions of the entire rectangle and look at what was cut off. So from the original sheet of tin, we had 15 centimeters of length, and we're cutting off x on one side and x on the other side. So what's left over is going to be a length of 15 minus twice whatever x is. So 15 minus 2x is going to be our length. Okay, for our width, it's the same idea, except what we're going to have is we have 9 centimeters of width. We took off an x from the top and an x from the bottom, so we're going to have 9 minus 2x. Okay, so we know that the area of this inside rectangle is 112, so that means our area, which is 112 centimeters, is going to be equal to 9 minus 2x times 15 minus 2x. Okay, so with that in mind, we actually have a quadratic equation. So it's a factor form on one side, but it's not 0 on the other side. So in order to be able to solve this, we need to expand everything out and have everything on one side of the equation. So the right side of the equation, those two binomials have to be multiplied together. So you can do that using distributive property or using arrays. So do that off to the side over here. Okay, so again, every box of the array gets filled in with multiplication. So in the top left, it's 15 times 9, which is 135. Okay, so the right side of my equation becomes 4x squared minus 48x plus 135. And again, that's all equal to 112. So if I want to solve this quadratic equation, everything has to be equal to 0. So I have to bring that 112 over by subtracting it from both sides of the equation. Okay, so now I have my equation in standard form, and it's equal to 0. So how do I solve this? It's using quadratic formula, or if it factors, we would factor it that way. So I'm going to see if it factors by calculating my discriminant, b squared minus 4ac. Okay, even if it doesn't factor, at least I've calculated part of the quadratic formula already. Okay, so all that's equal to 1,936 which is a perfect square, so this does indeed factor. So I'm going to go through and do it by way of factoring. If you would find it easier to use quadratic formula, feel free to do so, but we should end up with the same answers in the end. Okay, so I'm going to factor this. Okay, there's no greatest common factor I can take out here because 23 is prime. So I need two numbers that multiply to 23 times 4, which is 92. So two numbers that multiply to 92, but add to negative 48. Okay, after a little bit of work, I'm going to find those two numbers to be negative 46 and negative 2. Okay, so I have to look at what multiplies to 4x squared. 4x and x won't work because 4 doesn't go into 2 or 46. So I'm going to have to use 2x and 2x. Okay, so 2x times minus 1 gives me minus 2x, and 2x times minus 23 gives me minus 46x. So my factored form is going to be 2x minus 23 and 2x minus 1. Okay, so once I have it in factored form and equal to 0, I can now solve for x. So remember, to get my zeros, set each bracket to 0, or each factor to 0, and solve for x. So 2x minus 23 equals 0, and 2x minus 1 equals 0. So if I solve each of these, x will be 23 over 2, or 11.5 centimeters. Okay, and from the other one, I get x equals 1 over 2, or 0.5. So I have to ask myself, are both these answers valid? So if I take a look at 11.5, I can see that's actually not going to be valid because if 11.5 is longer than one of the lengths of the original sheet of tin. So the original sheet of tin was only 9 centimeters long. I can't possibly take out 11.5 centimeters from both the top and the bottom. There's not enough tin for that. So that makes that first answer inadmissible. Okay, so which means the only other possible solution is that x equals 0.5 centimeters, and you can see that actually is possible. I can take off 0.5 centimeters from both top, bottom, left, and right, and be able to make the remaining rectangle possible. So the only possible width of the strip is going to be 0.5 centimeters. Okay, so let's take a look at the next one. So we have a resort hotel that has 250 rooms, and a standard rate is $150 per night per room. During a non-holiday season, 100 rooms are rented each day, but they discover that every time they reduce the price by $20, they can rent 25 more rooms. So they want to know what price is going to maximize the revenue. So we've done questions like this before, and remember that the key here is to remember that revenue is equal to price times number sold. And the best way to set up this problem is to let x represent the number of price changes. Okay, and once we have that, creating the equation actually isn't too bad. We'll just deal with each part one at a time. So let's deal with the price first. So we start off with a price of $150 per room. And every time we change the price, it's a reduction of $20. So our price goes down $20 for every price change, or 150 minus 20x. So you lose $20 for every price change. Looking at the number sold, we start off with 100 rooms being rented, but every time we change that price, 25 more rooms are rented. So it's 100 plus 25 for every price change, or plus 25x. So right from there we have our equation, and it's already in factored form. So what we're looking for is the price that will maximize revenues. You see that word maximize, you're thinking something to do with the vertex, but we're not actually looking for the maximum revenue, we're looking for the price that gives you the maximum. So to find out the price, we need the number of price changes, so what we need to find first is the axis symmetry, so the x value that gives you the maximum revenue. Thankfully we're in factored form, so we can get the zeros. So for our zeros, we set each bracket equal to 0 and solve for x. So we have 150 minus 20x equals 0. Okay, and we also have 100 plus 25x equals 0. In each of these situations, we need to be able to solve for the zeros. Okay, so in the first case, we get 150 equals 20x. So x is going to be 150 over 20, or 15 over 2. Okay, in the second case, we have 25x is equal to negative 100. So solving for x there, we get x equals negative 4. Okay, so these are your two zeros. So to find our axis symmetry, simply a matter of adding those two values together and dividing by 2. Okay, so I'm going to leave you to work through the math here, but you should get an axis symmetry of 7 over 4. Or if you want to convert that to decimals, it's going to be 1.75. So what that tells me, again, it's not telling me that my price is going to be $1.75. That doesn't make any sense. But remember, x is actually the number of price changes. So we have 1.75 price changes to give us a maximum revenue. So if we want to figure out the price, what we need to do is then look at the price part of the equation, which is 150 minus 2x. So again, our starting price was $150, but we lost $20 for every price change, but there's going to be 1.75 price changes. So if we want to find out our optimal price, it's just a matter of running that through our calculator. So 150 minus 20 times 1.75 gives you $115. So if you charge $115 for the room, it will give us the maximum possible revenue. Okay, so always be wary of what part of the equation you're looking to solve for. This one asks us for a price. If it asks us for the number of rooms rented, we've had to use this part of the equation over here, the number sold. If it asks us for the maximum revenue, it would have put it into the entire equation and solve for R. So always look at what you're being asked to solve for.